Okay, so the next speaker is Sujit Dey. He's also a member of our department. Sujit got his PhD from Duke University. He then worked for NEC Research before joining UCSD. He's interested in wireless multimedia applications, and he'll talk about some of them right now. Thanks.
Thanks, Alon. Good morning, everyone. So today, I'll be talking about a new topic that has been emerging over the last, I would say, about a couple of years. We have coined it cloud mobile media. It can be coined in different ways. And I'll be talking today about the opportunities, challenges, and some directions that we and some other colleagues around the world are pursuing in this topic. So what is cloud mobile media will become apparent as I go through the talk. But very briefly, all of us have heard of cloud in positive and negative ways. And so this is mobile multimedia applications which make use of the cloud. Okay, so that's how I can briefly describe it. Okay, let's see. So what we'll be doing is we'll be looking at the mobile cloud computing paradigm, and in that context, cloud mobile media. And we'll be looking at the market outlook. What is the adoption going on today and what holds for the future? The types of cloud mobile media services and the challenges, and these are challenges that we have through various experimentations. We'll present some results to you. And then I'll be talking about some cloud mobile media solutions that we have been pursuing. And finally, while the cloud, as we know today, and most of you, all of you would be knowing about the Amazon cloud, the Google cloud, and so on, we'll be extending that cloud to into the wireless network, and I'm calling it wireless media clouds. So what we have seen over the last several years, this is, you may not have seen this particular picture. This is something that I have drawn, but all of you will relate to this. That on both the axes, on the x-axis, what we show is the miniaturization of the devices, but it's just not miniaturization, it's also the portability, and to most of us, to the consumers, it's the always present, always on, always connected nature of the devices that has emerged over the last several years. On the y-axis, though, is the functionality of the devices have kept on increasing, be it the computers, be it the servers, and so on. The functionality has just kept on going up at a pretty record-breaking pace. Now, across this dimension, you can draw various generations of the same kind of device. For instance, a phone which used to look like this is becoming thinner, more capable, et cetera, right? So, now the question is that as we yearn for this, that is always on, always connected devices, they are not, and yes, they are becoming, more CPU, better battery, and so on, but it's nothing like this axis, where the servers, the PCs, they have, kept on increasing in terms of their power. Now, one of the things that is interesting, that 2012 marks the year where global shipment of PCs have been surpassed by the mobile devices. All of us are pretty much aware of that. And in the US, it's predicted by 2015 that most people will be accessing the internet not from their PC devices, but from their mobile devices. And all this definitely leads to this desire from consumers that they would like to use the mobile devices and networks like we use PCs and wireline networks today. So where mobile cloud computing comes in is essentially this convergence which gives mobile devices, think of it, the capability of the progress of the servers. So as the servers keep increasing in terms of their capacity, and obviously mobile devices cannot keep on with it, and mobile devices, as I mentioned, is more towards the always on, always connected nature of the device. But if we have mobile cloud computing, then the server capability with the benefits of small footprint and mobile connectivity can be obtained in the same device. So that's the advantage, that's the attraction of mobile cloud computing. Now, so what is mobile cloud computing? I have drawn here, so essentially these devices, they do not have to rely on the computing on the device itself, but they can make requests. So the applications on the device, instead of really running on the device, can run on the cloud servers here. And of course, the requests have to go through the RAN network, through the core network, and onto the internet cloud. And then the application will run here, and the results will come back to the mobile device. So essentially, you can think of mobile cloud computing is going to encompass the best of the infrastructure as a service and platform as a service of cloud computing, but also need to incorporate the issues of working with the wireless network. So we avail of the infrastructure as a service, platform as a service, and software as a service that is growing around the cloud computing platforms, but at the same time, we have to manage this going back and forth over the wireless network. Okay, so that's how I'm defining mobile cloud computing as its biggest characteristic. Now, anytime a new area emerges, I ask myself the question, what are the chances of adoption? And what's going on in the commercial market today, and how can it be adopted in the future? So I don't put complete credence on various market research, but they give some ideas. And so some of the research is showing that, first of all, today, mobile cloud computing is being led by enterprise. So various kinds of enterprise applications. And consumer applications is growing, but still much smaller. So by 2014, the prediction is it will reach about $10 billion market. And other studies are showing that about 2016, it's a $39 billion market. So it's a pretty healthy market. Now, cloud mobile media, which is essentially not just enabling enterprise applications like Google Docs, name it, any number of enterprise applications. Cloud mobile media, where we are focusing on, is going to enable rich multimedia applications from mobile devices. So that, we believe, will be much, much bigger market than just the enterprise market eventually. So, for instance, it has already started emerging. Many of you might be already using various kinds of storage and download kind of services, either from Google or Apple or so on, and these are all cloud services. Playing your music on the cloud, for instance, with Amazon iCloud player. I don't know any of you are using it or not, but there are various kind of consumer cloud services that are already going on, which is about 6.5 billion by about 2016. But what I feel is going to give a huge boost to this is that all of us are very aware of all the apps, and I still don't understand and appreciate the value of all the apps on my device, but many people do. And as this app market has grown, and it's supposed to be about $25 billion market, by 2015, very soon, but this market is going to tilt towards the cloud. What I mean by that is that instead of the app developers, instead of developing their apps just based on this device, they're going to make full use of the cloud. And most of the apps are going to become hybrid, that is, making the best use of the resources here, for instance, location services, which is not available on the cloud, and making use of the potential of the cloud to do all the computing. So this is where I feel that the app market will be going, which will give a tremendous boost to this market. So what are the kind of cloud mobile media applications that we can envision? The first type I mentioned already, that is the storage and download. A lot of people are already using it. And the next types will be various kinds of audio, video streaming based applications moving to the cloud. And including cloud DVR and various different applications people are envisioning. Then we have interactive services. My favorite is remote desktop. That is, one of the reasons I don't use still iPads as much is because I don't have all the applications. I cannot use it as I use my PC. And with remote desktop, that problem will be gone. So everything will be running on the cloud, and I'll just be using my iPad as the entry to the to my world of applications. And that will make it very, very powerful. The other kinds of applications that we are starting to emerge based on the cloud are various kinds of rendering-based applications, including augmented reality, cloud gaming, and so on. And then, of course, with cloud, I expect media analytics to take off in a much bigger way than what it exists today. I mean, analytics is already taking off, but media analytics will be big in the cloud because the cloud service providers will have a much broader understanding of the various different devices, applications, and so on. What I've also listed here are the various features that need to be extended in the cloud. I'm calling them the infrastructure as a service features and the platform as a service features. And then the advantages of these services based on the cloud and the challenges. Okay, now I'll not be able to go over all the details of this, but very briefly, that the infrastructure as a service today really is generic computing, and that has to change, especially for the various multimedia applications. We'll need to see much more GPUs into the cloud and much more specialized DSP processing in the cloud. Also, we need to see much more focus on essentially data integrity, data availability, 24/7 availability, all those good features, and I'll come back to those things later. Transcoding, translating has to be much, much more powerful than it is today. As some of you who has exposure to signal processing know that transcoding, translating remains very, very compute intensive, and those things have to be done in the millions because all the applications will now have to be running on the cloud, and so that has to scale tremendously. Now, the advantages of any of these number of applications is really for the service provider low capex. You don't have to build out a network infrastructure or a infrastructure of servers. You can rely on the cloud infrastructure. So that's a huge advantage. And from a consumer perspective, the advantage is that, and also from a service provider perspective, the advantage is that whatever you're running on the cloud is independent of the various device platforms and the device footprints and so on. So you are running an application which is independent of the devices, and then any kind of devices will be able to access that application. So it really gives you a multi-platform, multi-device capability. And in terms of challenges, and this is the one that we'll be looking at more, from storage and download to interactive applications to rendering, there are two kinds of challenges. One is that cloud-based applications will increase tremendously the flow of traffic through our wireless networks. And the bandwidth consumed will become significantly more. And many of you have seen, for instance, predictions from the Cisco Visual Index in terms of video. Those predictions will be dwarfed if cloud mobile media applications take off, because all the computing is going to go on in the cloud, and all that video, all the data is going to come from the cloud. So that is going to be a big challenge. The second challenge is that most of the applications run on the cloud will become interactive applications, highly interactive applications. What that means is that instead of latency being a consideration, response time becomes a big problem or big consideration. And so managing response time will be a big challenge in this whole thing. The third challenge, I would say, across the board here is that because so much computing will be going on, instead of your devices, but on the servers, so power, energy, and all the other things related to applications running on servers becomes hugely important here. So let me tell you a little bit about one class of applications, which is cloud mobile rendering. That is, any kind of application where you need rendering, the rendering is being done not on your device, but on the cloud. Okay? So as I show here, that I'm running a rendering-based application here, but the actual application is not running here. My control commands are going all the way through the radio access network, the core network, onto some cloud mobile rendering server. The cloud mobile rendering server understands what I'm rendering and will be using the rendering engines to render the frames, and those frames will be encoded and streamed all the way back to the device. Okay. So this is a class of applications, and there are various kinds of applications which you can see here. For instance, as I said, cloud gaming, telemedicine, augmented reality, various kinds of applications. Okay. Now, why do we want to do that? So if I look at this chart here, and this is an example with cloud, example with gaming. So suppose I want to have the same kind of gaming instead of running on the device on the cloud, okay? Now, why do I want to do that? First of all, device capabilities. So if you look at this chart here, this is how the speed of the processors on our devices keeps on increasing. And actually, it's pretty commendable. But the requirement of the applications are going up at a much higher speed. So I'm comparing here 2008 versus 2011. The game that was most popular in 2008 was World of Warcraft. And these were the requirements in terms of the hardware and the storage. And this is what the best device platform had at that time. And you see a gap here in every different department. Now in 2011, the smartphone, again, iPhone was the best platform. And this is how the iPhone rated in terms of the various hardware capabilities. But that year, the game that became most popular and was released was Call of Duty. And this is what the requirements was. So as you see that as the devices keep on increasing in terms of their capabilities, the applications, of course, and especially rich graphics-based applications, keep on increasing what they need. And so obviously, this might have happened in your homes also. I don't know how many of you play games or how many of you have children who play games, but I have had experiences where I had to change my PC from now and then because my son could not play his game on that PC anymore. Okay? Now, that was PC, but now we are talking of enabling iPads or any other kinds of devices to play these games. What that means is much better to have the games played on the cloud as opposed to the device, because otherwise you'll have to keep on upgrading the device. The second, the other aspects here are obviously ubiquity of access, because now you don't have to download the rendering application, be it gaming or whatever, onto your device. It's running somewhere else. So you can access that application from any device. So that gives you ubiquity. For the developers of these applications, as I mentioned before, that single version for multiple platforms and devices. That's a huge advantage because if, many of you know that the wireless devices remain very fragmented. For instance, you cannot run various applications on your iPad today. And single mobile client for all CMR applications. Now, what are the challenges? So one of the challenges is to do with the wireless network. And I'm going to show through some studies that we have done. For instance, we implemented video streaming on Amazon Web Services. And then we saw what are the latencies and what are the packet losses experienced by the application as we are running the application, which is this video streaming on the Amazon cloud. And we did the experiments in various different conditions. I'm showing some snapshots here, where this is really done at 12 a.m. outdoor. That means unloaded network conditions. I'm sorry. So this is done at 5 p.m. outdoor. That means loaded network conditions. This is done at 6 p.m. indoor. That means loaded and noisy network conditions. Okay, so I'm increasing the burden on the application more and more. So what we see here is that the delay is going on, is fine here, and the packet loss is fine here, but not the round trip delay, the latency is going up as we have loaded network condition, and is going up even more, the blue curve, as we have loaded and noisy network condition. The packet loss also is becoming more and more as we have loaded and network noisy conditions. Now on the right-hand side, what we show is that this is a gaming application where you are playing the game on the device, and but actually what is happening is that the commands are going and the game commands are being rendered on the cloud. So we have an uplink delay, which is shown in green. We have in blue showing the downlink delay under the same kind of conditions, and we have response time. That is, from the time you give a command, what is the response that you are seeing? And what you see is that the response time becomes unbearable or unacceptable, because for most gaming applications, the response time should be, depends upon the kind of game, it should be either under 200 kind of milliseconds or at most about 500 milliseconds. And so it's crossing the threshold somewhere here. And there's a reflection of the user experience. We have come up with a score called GMOS, Gaming MOS. It shows that under these benign conditions, everything is fine. But here, the GMOS score is dipping below 3, which means unacceptable. Then we have the challenge of cloud cost. So cloud, as many of you know, has this big advantage that you do not have to reserve servers in advance, that it's elastic. That is, as your demand goes up, the cloud capability keeps going up with your demand, essentially. So it's a utility model, but the utility model has prices, and we have listed here different kinds of cloud providers, has prices depending from computing price to storage price to network price. And what we did was we took one of the applications, World of Warcraft, and ran it on these cloud providers and saw what it adds up. And essentially, it's going to be about 11 cents per hour to run a World of Warcraft session on this provider, and so on. So this is very expensive, because if you do the math here, typically a gamer plays about 24 hours per month, so it's going to add up to about $10 per month, which is unacceptable, because it doesn't. If the operating cost is so much per subscriber, then you cannot offer that service. I'm not going to go into details. And then what we did was we did some profiling. So this is on the left, you see a profile of players in China playing World of Warcraft. And so if we have to accommodate these players on one of the providers, and I'm not naming the providers, on one of the providers, which is the cheapest provider according to us, then essentially, depending upon the resolution that you play, it's going to cost you this kind of $1 million to accommodate those users per day, which is obviously unacceptable. So we need to bring down essentially the cloud computing cost associated with this kind of application. And we also studied how much it will cost in terms of per subscriber to bear this kind of, to pay the data rate costs for these services. And it comes to about, even if you're using 75% of time Wi-Fi network and just 25% of the time, say a Verizon or AT&T network, then the cost is going to be about $70 a month for smartphones and $155 per month for tablets, which is, again, it just shows that, yes, it has promise, but today as it stands, it's not scalable, it's not economically feasible. So what we started doing a couple of years back, and this is a growing field now, is trying to address these challenges. The challenge of the user experience, that is because of the wireless network, the problems with the response time, the problems with the quality of experience, the challenge of the cloud cost, the challenge of the mobile bandwidth, and of course, challenge of device scaling. And we have come up with various different techniques. I'll not be able to go into the details of these techniques. Do you have 5 minutes, Alan? Okay. So what I'll do is I'll just give you a very quick flavor of the techniques that we are coming up with. The first one I'll be talking about very briefly, and what I'm giving here are references to our publications, which you are most welcome to look at, is what we started doing is understanding what is user experience in the context of these cloud applications. Because remember, for cloud applications, you are issuing some commands, the command has to go, interact and get executed on the cloud and then come back. So there are various kinds of things going on here. One is, of course, what kind of video encoding parameters. The graphic rendering typically will get updated depending upon what the applications are. And we also have come up with adaptive graphic rendering techniques, which I'll talk about very briefly. Then the compute resources, depending upon the load on the resource, will sometimes add delay, latency. The wireless network, of course, has its own issues of packet loss, delay, jitter, and the mobile client has its own capacity issues and playout buffer issues. Okay, so all these objective factors lead to these subjective visual experience and response time issues, which lead to the user experience. So what we did was we tried to model this whole thing in terms of user experience and came up with a model not only which is theoretical, but which is quantifiable and demonstrable on any kind of wireless network. So our user experience models work with any commercial wireless network that exists today. And what we did was we did some subjective studies to come up with what each of those factors, how each of those factors affect the cloud experience, and then came up with these models. And then we validated the models with another subjective study where we varied all the different parameters and then asked people to score versus what our model predicts. Okay, and we see that it's a pretty good correlation, and we are keeping on improving our models. Then we have been developing, and we have a demonstration outside today at 2 p.m. or 2:30 p.m., something like that, where we demonstrate this platform where we can do mobile gaming from the devices, from any of the devices here, and the game engines will actually be executing on the cloud. And so here what we do is we monitor the network on the fly. We try to understand how the user experience is, how the response time is, for instance, and then we have developed some novel application adaptation techniques which adapt on-the-fly rendering. So you can think of, as we have developed in the past, scalable video coding techniques, so have we developed here scalable rendering techniques, which can understand the network conditions and then adjust what kind of rendering you are doing so that it's compatible to the network condition and the device. And with that, we can manage the user experience and keep it at a high level, irrespective of the network condition. I'll skip through these. Just one more thing I would like to mention to you, which is very interesting, and that is associated with cloud computing. There's a lot of research going on cloud scheduling. That is, how to enable these diverse tasks, heterogeneous tasks, to be executed efficiently and fairly on cloud computing platforms. Now, the cloud computing platforms are very interesting because they are very heterogeneous. For instance, Amazon Web Services, amongst other service providers, provide various different kinds of computing resources, okay, and with various costs. So these techniques are trying to map the needs, the computing needs of the applications on these different kinds of heterogeneous cloud computing platforms. What they don't do is take into consideration the wireless network situation or the wireless network constraints. So what we have initiated is a study on what we call wireless cloud scheduling. What that means is scheduling which is coordinating both with the wireless RAN as well as with the cloud computing resources. So essentially the objective of the scheduling is to accommodate as many users, cloud users as possible on the available wireless networks while minimizing the cloud costs. And so this is again an exciting area of research which is just emerging. And as I've said that all our initial papers I have listed here so that you can potentially take a look at them later. And lastly, I'll just want to end with this slide, and that is, imagine, so today cloud computing, as I mentioned, is all in the internet. But imagine cloud computing coming very close to the edge of the network, on the RANs and in the core network. That means small cloud computing resources together with storage, filling up our core networks and our radio access networks. In that case, we can have similar kind of applications run much more efficiently at the very edge of the wireless network with much lower latency. The challenge will be how to divide up the computing, because now we don't have these huge servers. We have much smaller servers and smaller caches. Okay? So with that, I'll want to end this, and conclude that there are other challenges that I skipped over. Of course, security is a big challenge here. Energy, as I mentioned, is a big challenge, and so on. What I would like you to think of as wireless cloud computing as really a convergence platform, convergence between all the cloud computing and the wireless network and the advances in devices. And I asked myself that what kind of applications, media applications, can we develop if our mobile platform has 10x more computing capability, but without paying the penalty of battery. That is, I can still have 5x more battery life. And that, I think, opens up totally new opportunities of developing different kinds of applications. Thank you very much.